Let's talk about how to evaluate a regression model. So we have to figure out a way to evaluate the closeness of the truth to what we predicted, which is f of x. So here's what I proposed earlier, so y minus f. And we didn't like that because we could have equally proposed this one. So we want to use something that penalizes mistakes in either direction. So we could use that the distance, this is the distance between the truth and the predictions. And we could assess the mean absolute error, which is the sum of these things. That's one way to do it. But you could also square all of them and get the least squares error, or the sum of squares error, or the mean squared error. And you could think of it as capturing errors in both directions, like the absolute value that we had earlier. So same deal, penalize how far y is from f in either direction. And then the root mean squared error is just the square root of the sum of squares error. Now, switching topics slightly, let's talk about residuals. The residual, or error, is just the difference between the predictions and the truth. And obviously, we want all of these to be close to 0. And we also don't want to see any sort of structure or pattern in these residuals, because then it would mean that there's more modeling that we have to do. So let's discuss this a bit more. Now, we want the residuals to be as close to 0 as possible. We don't want any apparent pattern in them. So what I'm going to do here is I'm going to plot a histogram of all of the residuals, yi minus f of xi. And where this histogram is higher is where most of the residuals are. And ideally, they're mostly close to 0. Okay? So this would be good. Most of the residuals are around 0, and there's no pattern in the residuals. If you see this, you can smile because you know you did something right. This, on the other hand, is bad. Right? This probably means we missed something. So what could explain a plot like this? Right? Maybe we're modeling the data with one line or something, and actually the data falls into 3 lines or something, which is why there's 3 bumps. Maybe we just missed the other 2 lines. I don't know. And I can't tell exactly from looking at just this what's going on. Now, in order to figure out what's causing this, we have to figure out what factor is common to everyone in this bump, and then we have to figure out what's common to everyone in that bump, and then we have to include those extra factors in the regression so that we can model whatever signal is there and try to get rid of all those bumps. This is also bad. Right? Perhaps here we just have the wrong model. There's lots of points we are just not describing well. Okay? We have a ton of points that are nowhere near f of x. Not good. Now, this is the list of features from the automobile pricing data set. And we have all of these factors about each car, and then we're trying to predict the price. And we're going to do regression using a couple of these features to try to predict that price. Now, if you're curious, we actually use the features called fuel type, which is either gas or diesel, engine horsepower, type of aspiration, which is turbo or not, and curb weight. And we use those things to predict the price of a car. And this is a plot that's produced by R that shows something interesting. So along here, along that axis, is the estimated price. So the more expensive cars are over here. Now, I just want you to pay attention to the points here. Each point is a car. So you can see that for the cheaper cars, our predictions are pretty good. Right? The residuals are close to 0 for the cheaper cars. But then we get to the more expensive cars, the predictions get worse. Right? Our predictions are farther from the truth. So why might that be? Well, we do have a larger number of cheaper cars. So the regression model is going to try to fit the cheaper cars better just because there's more of them. But also, I was talking to Steve about this, and he thinks that it's because the more expensive cars are actually more diverse. So you just can't predict very well for the more pricey cars. What the heck is that? Right, that guy? We didn't get the price on that one right at all. Now, this car happens to be an expensive 12-cylinder Jaguar with some unusual properties. It's actually a 2-seater with a huge hood and an enormous engine. Now, actually, this plot has the cars colored by the number of cylinders. So you can see that we predict better for smaller number of cylinders than we do for larger ones, which I think is pretty interesting. So we might want to think about, putting the number of cylinders into the model. And then here is a residual plot, which is, again, the histogram of residuals. And luckily for us, it's nicely centered at 0. And here, my friends, is the jaguar.